So we're going to talk now about the pacemaker action potential, right? So we said what the pacemaker was. What is it? It's part of the SA node sinoatrial nerve that's located in the walls of the atrium, specifically the right atrium, right? And the function of the pacemaker is to generate an action potential, a sort of conduction that goes down into the atrioventricular node, eventually to the bundle of His, and then the Purkinje fibers in order to generate a contraction of the ventricles, right? And so just like other systems, for example, the nervous system, the way an action potential is generated is through the changes in gradient of the ions, right? So if you remember before that we were talking about, if I grab a cell, okay, and in that cell, you want to know that there's three ions, cations, that are important, which is regulating the actual electromagnetic potential of, not the electrostatic potential of the cell. So the three types of elements of sodium. So there's a higher concentration of sodium. So I'm going to write this in caps, indicating higher concentration of sodium on the extracellular space. So ECF versus ICF, intracellular fluid, or intracellular fluid, or the extracellular fluid, right? And then you have potassium, you remember from the nervous system, so there's more potassium on the inside, okay, versus the outside. And you remember from the nervous system that it was a passive process, right? So channels would open, the ions would move from a high concentration to a low concentration. Now that we're involving the cardiac muscle, right? We have a new cation that's really relevant now, and it's calcium. So you have very low concentrations of calcium on the outside and the in relation to the cell. However, there's a higher concentration of calcium on the outside of the cell, so in the extracellular fluid, right? And so this specific graph is showing you again the changes in the gradient of what's happening. All right. So you begin here at number 1. So number 1, there's these specialized channels called the IF, the funny channels. These also are another form of sodium channels, right? And so at 1, sodium channels open. So these sodium channels open in order to reach this little threshold that I just drew right now. Okay? So the sodium channels open. You have an influx of sodium, right? Because you have more sodium on the outside going into the cell, right? Remember, a passive process. And this causes a phenomenon of depolarization, right? So these cells are negative, right? So around negative 65, if you want to put a negative 65 here. And they begin to depolarize, so they become more positive. As soon as they reach this threshold here, these funny channels close, and then now you have your calcium channels open. So now you have your calcium channel. So from this little circle, you notice that there is a higher concentration of calcium on the outside. So what happens? It's a passive process. It goes from a high concentration to a low. So calcium goes into the cell. And that's why you see a further depolarization, right? So it becomes more positive, until at 3, where you have your actual action potential that's generated. So now you have the action potential that is generated at number 3, okay? At number 3, all of your calcium channels close. So the calcium channels close, and you have now the potassium channels that reopen. So now you have potassium channels open, right? After the calcium channels close, right? And then finally it reaches back to the resting potential, right? So there is no excessive hyperpolarization that you remember from the nervous system, whereas a pacemaker only goes into a resting potential, and it continues on. So this is 4, right? This is the repolarization phase where the potassium goes out of the cell. So you have potassium leaving the cell, repolarizing it, making it more negative until you reach, again, number 1, which is where you have the resting, quote-unquote resting potential, and it further triggers, again, the funny channels of the sodium channels to open up, and then continuously this process, etc. Okay? This is the pacemaker action potential.